If you enjoy board games, or you like to go to the casino and play on the crap tables and all that sort of clever stuff, you'll realise that one of the problems is that you have to use a dice, which means an awful lot of physical effort. Well, fortunately, Velleman have come up with a solution. It's the Velleman Shaking Dice MK150, an electronic dice. Something we all need in our lives, no doubt. Well, let's put it together and see what it's all about. Can't say it's one of those things that most people are going to want in their lives, but we'll soon find out. I'm having to cut this open with a scalpel because Velleman, in their wisdom, have decided to weld the damn thing closed in this packaging, which is a bit of a pain to open. So there we go, that's seen that off. So let's see what we've got inside the kit. Many pieces, yes, we don't need that. We do need this, which is the circuit diagram and the instructions, which come in many languages, as you can see. So I'm hoping this will be a fairly straightforward little kit to put together. So let's see what we've got in the box. We have a bunch of resistors, a PCB which comes in two parts, which no doubt we have to snap apart, which is fine. And oh look, a Velleman sticker. I didn't get one of these in the other kit. That was the running microbug, if you recall. This is a fun little kit, by the way. I was quite impressed with this. Yes, so let's see what else we get in the kit. A plastic bag full of goodies, including hardware and a little chip, and some screws and many an LED. Let's put these over there. I say many an LED. We've got half a dozen, presumably. Nope. Yes, I don't know. What have we got here? We have got a chip, which is, oops, upside down. Let's see if I can show you through the camera. It is a 12F508. Yes, that means nothing to me. So there you go. We have a battery holder, but we don't have a battery, which is unfortunate, but never mind. We have a, whatever the hell that is, I have no idea. I expect we'll find out as we go through the instructions. A bunch of hardware to put the two halves of the main board together. More LEDs. And a different value resistor there. Check the values of these later. Socket for the single chip. An electrolytic capacitor of the value of 10 microfarad, 35 volts. Don't think we're going to need 35 volts, but there you go. And whatever this can is, looks like a crystal, I suppose. I assume that's a crystal. So that's the whole kit in terms of parts. So yeah, let's start putting it together. Right, okay, so this is not a crystal, it's actually a switch. So it's, I don't know, reed switch. No, it's not a reed switch, is it? And I don't know if it's, yeah, it's a, you shake it, I think it's got a ball bearing in there, which obviously if it goes one end or the other, will, I am sure, cause it to switch the circuit on and off. So yeah, that's a neat little idea. It's a shaking dice, so when you shake the whole unit, then obviously that little ball bearing or whatever it is in there will make it power on and off. We need a CR2032 battery, which I don't know if I've got any, actually. I think I might do, but we'll worry about that once we finish building. These are, I think it's 560k resistors, and that's a 1 mega ohm resistor. So it's all fairly straightforward, not a great deal to worry about here. The LEDs will be inserted into the LD, light emitting diode, I suppose that stands for. Sector spots here, and you'll see one's got a marked side, and that's where the cathode will go, which is the shorter lead of the two on a LED. So it will be this side will go into the marked side on the board. That'll be for all of those. So yeah, what do we start with first? Okay, so we've got the instructions here. I think the first thing to do is the resistors. That's always usually the best place to start, is to do the resistors. So I think what we'll do, so we don't mess it up, is get the single 1 mega ohm resistor installed first, and that is, where is it? R8 is 1 meg. So let's find out where R8 is on this board. And there it is there. So let's start putting that in like that. Okay, and then let's do the remaining resistors. You'll see that's R1 to R7. That's the 560k, I think. So let's get all these resistors out, R1 to R7. And like I say, what I always like to do is I always start with the resistors, because they're usually well planted onto the they sit very neatly onto the board, so tend to leave the larger items like that and the battery holder till last, so we can get the fiddlier components done first. So let's get all of these bent into shape like that, and then start populating them onto the board. So there's our 5. Doesn't really matter what order we put them in. I'll just splay the legs out like that, just holds them in so it's easier to solder when it's it comes to do that. And then we've got R6. R3. Can you see? You can't see. I'm sorry about that. One of these days I'll get myself a dedicated camera, but I don't really think I need to be honest, because all I use here is my mobile phone, which seems to give out reasonable audio and video for jobs like this. So right, so where else have we got a resistor kicking about? We've got R1 here. Only problem with doing it like this, oh, and I've broken it, look, it's snapped in half. Well, it's supposed to, isn't it? So that's not a problem. It's 2 separate boards. And R4. Probably should have stopped and soldered the other ones up by now, because it's now going to be a bit fiddly getting the iron in there, but oh well, I've done it now. And R2, D2. There we go. Right, so that's them. And now I'll just sort out my iron, which is now up to temperature, and start soldering away. Bit boring to watch, I know, but if you're not into soldering and you've never soldered before, then a kit like this, which incidentally I got off of Amazon, so if you want to search Velleman shaking dice on Amazon, I actually got it quite a while ago, so I don't think there's much point in putting the link up there now, because I expect that link has probably moved on. But yeah, check that out on Amazon and see if you can get one. But you know, a kit like this is great if you're not into soldering, and everything is through hole components on this. There's no surface mount stuff, so yeah, it's a great little kit to practice your soldering. And again, as always with these things, it's, you know, if you've got children, obviously not leaving them unattended with a 380 Celsius soldering iron kicking around. You don't want to be doing that, but you know, might be a nice little project to do with them. Right, so I'm going through solder here like they're going out of fashion, mainly because of this very, very thin solder that I've got rather a large supply of, so I might as well use it. But yeah, these are nice kits to start off with, and they're also good quality. Velleman have been doing this for a long time, I think, and they certainly know how to make a decent electronic kit. So is this still in the... I don't even know if you're in focus. I mean, there we go. The autofocus on this phone is it's an iPhone 11. Excuse me. And I don't think the autofocus is that good on it for something like this. Let's be honest, mobile phones are not really designed to do jobs like this, I don't think. A lot of YouTubers do use them though, and yeah, why not? If it's good enough, then fair enough. Right, is that all of them done on that board? Nope, there's one there. Yeah, I'll probably put too many resistors in at once here. It's probably just do 3 or 4, something like that. Solder them up, and then snip off the legs. Let's do this board, and there we go. And as I say, you know, this is an easy enough kit. It's just a case of putting the right things in the right place and soldering them up. Resistors, it doesn't matter which way they go round. They don't have a polarity, so you don't need to worry about that. But those components that do have a polarity, let's have a look at those in a moment. Okay, so that's all the resistors in. I think what we will do next is let's do the LEDs. Let's go mad. Do the LEDs. Now, like I said, the short pin, or the short leg, that one there is the cathode, long one being the anode, or negative and positive if you like, and the short one goes on the side of the mark on each LED, like that. There we go. And what I do with these, and I'll notice that isn't actually sitting perfectly flat on the board. Oh, yes it is. That's not so bad. What is it? I'm looking through the camera, which is not a good idea. No, it isn't fitting quite flat on the board, because I thought there might be. Yeah, they see they're not quite flat as the pins go into the LED, so they do sit a little proud. But the best thing to do with these, I find, just to make sure, because it's important that the LEDs are nice and flat so it looks right. So what I do with these is heat up my iron, which I've switched off because I had a bit of a break a minute ago. So let's warm that back up again and get a bit of solder. Okay, so the best thing to do with these is just to actually put a blob of solder on one side, and this is warmed up yet. Is it? This is very fiddly. There we go, just a bit of solder on one side, and you can see that the LED's a bit crooked, so get your finger on it and then reheat that bit of solder until you've got the LED nicely positioned, or neatly positioned. There we go, like that. How's that? And then you can solder, clean my iron up a bit, solder the other leg of the LED like that, and then resolder that one a bit better, I think. And there we have it. So that LED is sitting neatly on the board. So let's just cut the legs off of that. So I'm going to do the remaining LEDs in exactly the same way, and we'll move on from there. Okay, so I think the next component that's critical for polarity is going to be the electrolytic capacitor, and you can see that one side is marked with a minus sign being negative and nothing on the other side, but as with the LEDs, you can see the short lead is negative and the long lead, that's positive. And unlike the LEDs where the negative or the cathode is marked, with the electrolytic capacitor, you can see there's a little plus sign there. So that means the long lead goes through the plus sign, like that. And the short lead, like that. I think, yeah, I think I'm just thinking actually whether that, no, it does need to sit, yeah, so it does need to stand vertically, like that. So, rather like with the LEDs, I'm just going to, for neatness, put a blob of solder. I've really got the camera mount in the way here. It's not working so well. I'm going to keep on knocking the camera, and you're probably feeling seasick, so my apologies. But let's just solder one side, then heat it up whilst pressing down and on the capacitor, like that. And that keeps it fairly neat. I just need to solder the other side. I think what I'm going to do is lift you up a bit. You lifting up? You are lifting up. And then if I just zoom in a bit, then that might be a bit more sensible. How's that working for you? Hopefully so. And it would be a good idea actually to have some of those helping hands doodahs with the old crocodile clips on them, just to hold it still while you're doing stuff. I have got a couple of those, but I just can't be bothered to go and get them at the moment. This will do. Okay, so that's the electrolytic capacitor in. The next thing is we do have a capacitor there, which is a C1. Now the only other capacitor we've got is this guy. So that must be for C1 there, I would have thought. 100 nanofarad cap, I believe that is. So let's get all of this guff of it. Actually, let's just snip them off like that, and then that can go through there like that. And there's no polarity on that one, so that's fine like that. And again, just do one side initially, reheat it, seat it well, and it'll just look a bit neater. Yes, I really do need to get the helping hands out. So actually I think that that's a bit loose. It obviously didn't take so well. Let's try again. That's better. Yep, that's fine. Do the other side. Like that. Cut off the leads. And that goes in there like that. Right, so the next thing to do is to get the socket for the IC, and as you can see on the socket, there's a half moon cut out of it there, and that maps with the silkscreen half moon on there, so it goes that way around like that. Looking through the camera just doesn't work. I'll get in. Right, so that's in. And I think with this one, I just grab my manky bit of blue tack just to hold it against the board whilst I solder up the pins. Yeah, there you go. And just like that. Don't need to trim the pins off because they're so short. They only just make it through the board, so that's fine. And the last one there. That's okay. Take my blue tack off. Ooh, it's a bit wonky. And so's my cap. Yes, that's a bit wonky. And I haven't really done a very good job there, have I? Never mind, I'm not going to desolder it just to straighten that out. God, I'm not that much of a perfectionist. I'm not a perfectionist at all, as you can tell. Right, what have we got left? We've only got... we've got a... What's that for there? Oh, that's... okay, so we need to put the battery holder in, but we also need to put the switch in. And the switch is... Now, that's interesting. You see here, it's got a blob of solder put on it like that. I'm wondering whether the idea is, so there you go, you bend one leg, put a blob of solder on it, and then bend and insert. And I'm wondering if it's because it needs to be at a bit of an angle. So the actual, so if my finger was the PCB, it kind of sits like that. No, it'd be like that, wouldn't it? Raised up. I don't know, a bit odd. I've never used one of these switches before. And I've also lost it. earth have I done with that? That's gone. It's disappeared. It's run away. I'll find it. So yeah, that's a bit of an odd requirement though. Well, I have definitely lost that switch. I shall go looking for it. Right, I found the pesky switch that tried to run away from me. So, as per the instructions, it wants us to bend one side like that. And then, I'm wondering actually if the idea is you have to bridge that pin to the outer casing. I wonder if that's what they're saying, because it does kind of look like that's what it's doing. Okay, let's see if we can do just that. Not the easiest thing to do, when I thought, but we'll give it a go. Now, I've lost my solder already, so that's fair enough. We'll find another bit and see if we can create that blob that they're suggesting there. Not sure why that is, or what it's for, what it's trying to achieve, but I suspect it's trying to make a connection between the pin and the metal case of the switch, which sounds a bit odd to me. Okay. This feels wrong. And I can't say that I'm bridging it too well, and I don't really want to knacker the switch up by overheating it, which is probably too late now. I don't quite understand that. Why would you want to bend and insert? Solder it? It does look like that's what they're doing, is bridging the metal case to that pin with solder, which I am yuck. I think I'm sort of melting the end there. Okay, I need to see if I can just carefully, because this is getting quite hot now, if I can just bridge these two down. Doesn't make sense to me though. Yeah, this isn't working. Okay. I'm making a right mess of that. If I'm not careful, I've just completely and utterly knackered that switch up. It's still rattling about. Yeah, okay. I'm not sure what's going on there. It might be easier to do it on the board, so let me have a quick think about this. Right, okay. I'm just looking at the circuit diagram. There's the switch there, and it is a rolling ball switch. Didn't see that earlier, but there you go. I can't see that it's bridged. Right, I think what I'm going to do is I really don't want to heat this up anymore, because you can see it's started to melt. And I just don't get the idea of that blob of solder. Let's take that off. Well, if it does need to be done, then I can always try doing that once it's in. So if it doesn't work, then I know what's going on. But yeah, and also the switch has got a marking this side, but not that side. It seems to have a minus. I don't think that's right. I don't know. It's just not very clear what it's trying to do. Right, okay, well I'm just going to solder it in and hope for the best, because this doesn't seem to make an awful lot of sense to me. And I've just seen that that leg is now moving. which gives me a horrible feeling I've just gone and knackered that switch up. Ugh. Yeah, that's not good. Let's see if I can push it back in at all. Yeah. Yeah, the ball's still moving around, but I have completely misunderstood what it is they're trying to tell me to do with that switch. It doesn't say. Just trying to have a look at the diagram to see if there's anything that suggests the manner in which that switch should be installed. You see, if we have a look at the diagram, so that's the chip and the switch would be there. So get that out of the way. So that's the resistor and the capacitor, and that seems to be flat on the board to me. It's not, I don't know. I just hope I haven't completely knackered the switch up, because it's clearly only a bit of plastic in the ends there, and you can see I've absolutely butchered that. Oh, that is annoying. And the space on the PCB versus the length of the switch, yeah, I don't know. Okay, I'm just going to try and solder it in kind of temporarily. I'm missing something here, aren't I? Probably a brain. There we go. Not very pretty, but it'll do. Oh, and it's fallen out. At least I can fit it in. But the can of that switch is a lot longer than the amount of space you've got on the board to fit it. It is really quite weird. Still, I'll try and it doesn't want to stay in, does it? Let's bend the other leg. I don't want to bend that leg because that one's fragile, so let's get the old blue tack out just to hold it in while I solder at least one end up. And like that. Okay. What a mess. Hey ho, never mind. Let's finish putting it all together and see if we can salvage anything out of this, which I think is going to be touch and go. Right, so that's the battery holder. Goes in like that. I've got the capacitor in the way. No, that's okay. Of course, I've got to try and find a battery for it. See if I've got a CR2032 kicking around that we can test this with, because we're almost done. I think the only thing left to do is the hardware once I've soldered this in. Right, so that's the battery holder in. Let's shorten that leg. Might regret doing that, but never mind. Okay, so the next thing is basically putting it together, and that is achieved by the hardware and these metal standoffs, which act as connectors to connect the two boards together. So obviously this side's got the power and the brains. I haven't put that chip in yet, have I? A good idea to put that in. Again, you see the polarity of this is important. You've got a little dot there, you've got the half moon, and that needs to match up with the socket on its half moon, like that. So let me just grab this and then just push it in. Again, slightly wonky, but never mind. I think it's all connected up. Okay, so yeah, let's make some space here and get my screwdriver out, and we'll start putting the hardware together. Right, so the actual orientation of each board is going to be like that, with the power or the battery and chip side underneath it like that. So that's the correct position. So if we take a screw and the first of these standoffs, then it's going to stand like that. Let's get another screw. Put that one in. Oop. And yeah, one at each corner. So let me do that. Right, well, that is the construction complete. And you even get 2 spare screws with it. No, you don't. I've just realised I haven't fitted these in. Oh dear, oh dear. So there must be another. Yeah, so that one, that needs to go in here. Like that. I thought I had 2 spare screws, but instead I missed one of the standoffs, which wasn't too bright. And as you can see there, I've also managed to find a CR2032 battery, so that hopefully we can bring this to life. Although I'm not entirely convinced we can if I've gone and screwed that switch up. Right, let's tighten that one down. Right, there we go, so it looks like that. Okay, so next trick, to get the battery inserted into the device, which, I don't know how good this battery is. Oh, look, we have, ooh, right, hang on a minute, let's try and make the light a bit more. So there it is, so let's try shaking it. 4, 4, 5, 2, 2 again, 1, 1. Just having a look at the orientation of the switch, so you probably want to do it like that. drive, shake. Something a little bit weird going on there, but it does seem to want to come up with the same number all the time. And now it's changing voluntarily. Or is it? Ah. So there you go. If you don't move it, it flashes for a few seconds and then powers off. And if you pick it up, it actually doesn't take much. It's actually very sensitive, that ball switch. 4. 3. 3 again. Oh, or was it off on a trip again? 6. 6 again. And a 1. I think you have to shake it after it stops flashing, by the looks of things. So that's a 2. It flashes, stays 2. Now it's ready to be shaken again. Well, it seems to be going off on its own there. Perhaps that switch is a bit iffy. There you go. Right, so it's finished on 2. So there you go. That's the Velleman shaking dice, which was a bit more of a complicated build than I thought it would be. Well, messy build, not complicated, but it's quite nice little kit. Good quality again, is Velleman, so you'd expect it to be. And it does work, although I really don't understand that switch with the blob that you're supposed to put on it, and which I haven't actually done because I was starting to destroy the switch, as you saw. But there we go. It does seem to be functioning in a manner that it was designed to. So there you go. I hope you enjoyed that little kit. And I've got another Velleman kit to do, which is a bit more in-depth than this one. So until the next time, stay safe, and we'll see you soon. Cheers for now.